Look at this graph. This graph describes the relation between distance and time, and this graph is called distance time graph. Can we describe this graph, or can we describe the motion represented by this graph? Of course, yes. But firstly, we have to look at this. We have here two axes. We have here the horizontal axis, which is time, x-axis, and we have here the y-axis, or the vertical axis, which here represents the distance. And the most important axis here is the distance. We'll see here how the distance changes as time changes. Look at this. As time changes, what happens to the distance? Does it increase, decrease, or what? For example, here, if I say that the distance is in meters, and this point here is 20 meters. After 1 second, for example, the time is in seconds. After 1 second, what is the distance? 20 meters. After 2 seconds, the distance is 20 meters. After 3 seconds, the distance is 20 meters. So as time passes, the distance remains the same. This means the object here so this graph represents an object which is stationary object, or an object at rest. Okay. Now again, we have here the distance doesn't change as time passes. This means the object is at rest. Okay, look at this one. What is on y-axis? It is distance. What is on x-axis? It's time. As time passes here, what happens to the distance? The distance increases. For example, here after 1 second, the distance is, for example, 5 meters. After 2 seconds, the distance changes, and so on. This means the object is moving. When the object is moving, this means its speed has a magnitude, has a value. This value, is it constant or varying? As long as you remember here, speed equals distance over time. So the speed represents the ratio between distance and time. I have here this straight line, means that the ratio between distance and time is always the same. This means the speed here is constant speed. So this graph, as long as, again, we have here a straight line between the distance and time, this means the object is moving at a constant speed because this is a straight line. So this graph represents here a constant speed. Understood? Good. What if the line is no longer a straight line, like here? This means, again, the ratio between distance and time is not always the same. Look at this. It is not a straight line. This means the distance changes in different values when the time changes at equal values. For example, every second here, the distance changes with different values. The same thing here in, for example, if we say that this is graph C and this is graph D, in graph C and graph D, the distance changes irregularly with the time. Speed equals distance over time. But the graph is no longer a straight line. This means the speed is no longer constant. The speed here changes. The speed changes. What does this remind you of? This reminds you of when the speed changes, acceleration exists. So when the speed changes, acceleration exists. So we have here acceleration. We have here acceleration. This acceleration, as we remember, the acceleration can be either positive acceleration when the speed increases, and we have the negative acceleration when the speed decreases, and this is called deceleration. So look here. In the beginning of the time here, the distance increases, but not as big as when at the end of time here. Look at this one. In this time, the distance changes greatly. Look here, the distance doesn't change as big as at the end of the time. This means what? This means the ratio increases between distance and time. This means the speed increases. So we have here small speed, or we have here the object is slower and the object here is faster. This means we have here acceleration. So the object in this case is accelerating. What about graph D? Look here. In the beginning, as time changes, the distance changes larger than at the end of the time. Okay, this means what? This means the ratio here is greater than the ratio at this point 1 is greater than at point 2. What does this mean? This means we start with a higher speed and we end with a lower speed, or the object becomes slower. So the speed here decreases. Decreases, this means the object is decelerating. So if we have a distance time graph and we don't have a straight line, we have a curved line, this means we have a changing speed. Changing speed means acceleration. It can be positive acceleration when the object is accelerating, and it can be a negative acceleration or deceleration when the object decelerates or when the speed decreases. Understood? Great. Look here. I have here this graph. It's distance time graph. And we have two objects, object X and object Y. Which object is faster according to the graph? Which object is faster, X or Y? And why? Okay, very good. We see interval of time and we see which one covers longer distance. Again, we see or we determine which one covers longer distance in the same time interval. Let's see. For example, here, well, take this point here, okay, to represent a specific time interval here. And we see which one covers a longer distance. Look at object Y. It covers this distance. And what about object X? It covers this distance. Which one covers a longer distance? Look at this. Y covers only this distance and X covers all this distance in the same time interval. Which one covers a longer distance? X. So X is faster than Y. It covers longer distance in the same time interval.